Hi, this is Mrs. Champagne, and we're going to learn about indirect measurement. Let's start with example 1. An office building casts a shadow that is 55 feet long. So here's my office building in green, and we have the sunshine up above. The sun is shining down on that office building, and where the office building stands, we're seeing a shadow that's being created on the ground of 55 feet. We can certainly measure this shadow length of 55 feet on the ground. So let's look and see what we have next. A person standing nearby casts a shadow 3 feet long. If that person is 6 feet tall, how tall is the office building? So we are solving for the height of the office building. Notice that all of our units are in feet. We have 55 feet long as the height is the length of the shadow. 3 feet long is the length of the shadow associated with the person, and 6 feet is the height of the person that's standing nearby. So that means we have to be solving for the height of the building in terms of feet. So why are we talking about indirect measurement, and what does that mean? Well, what it means is this. We can use indirect measurement as a way to estimate the height of things that are practically difficult to measure the height of. For example, if we were looking at this building and we were asked to tell someone, how tall is the office building? How would you do that? You could buy thousands of rulers and tape them to the side of the building end to end, but that wouldn't be very practical. We could stand at the top of the building and drop down a measuring tape until it hits the ground. I don't think that's very practical. So one way that we could figure out or estimate the height of the building is by looking at a proportion. And so when we talk about indirect measurement, we're talking about using a proportion to solve or estimate for the height of an office building. So let's look and see what a proportion would look like. I'm going to use all the proportions associated with the office building in green ink. So we're going to look at the ratio of the shadow created by the office building over the actual height of the building. Okay, so this is going to be associated with the building. Now I'm going to refer to my person in blue. So I'm going to set up a proportion, meaning that I have two equal ratios. Let's go ahead and see what that's going to look like. So for my person, I'm talking about the length of the shadow over the person's actual height. And again, this ratio has to do with our person. Let's fill in the height of the person. The height of the person is 6 feet tall. What we don't know is the height of the office building. So that's going to be our x, or what we're looking for to solve. In our word proportion, we can see that the height of the building is going to be this slot in the proportion. Let's go ahead and fill out our proportion. So again, we have shadow height associated with the building, or length of the shadow associated with the building height. So let's go ahead and write that. The length of the shadow is 55 feet. And you see I'm going to use feet in my proportion. Over the height of the building, which is going to be this part of the proportion, that's the part that we don't know. That's the part we're going to solve for. But we know our answer is going to be expressed in terms of feet. I'm going to go ahead and write an equal sign because I'm setting up a proportion. And then I'm going to write another proportion that relates the shadow to height of the person. So the length of the shadow associated with the person is 3 feet. And this person's actual height is 6 feet. So now we have this proportion that we can use to solve for the height of the office building, which is right here where the x is. Let's make sure that we understand how to set up the proportion correctly. If we look at the numerators in both ratios, they are both referring to shadow length. Now let's look at the denominator of the ratios. They are both referring to actual height. So the 6 feet is the actual height of the person that's standing nearby the building. X is going to be the actual height of the building. So now we have a proportion because we have length going across the numerators at length of the shadow length, 55 and 3. And across the denominator, we have actual height. X is the actual height of the building. 6 feet is the actual height of the person that's standing nearby the building. At this point, we just need to solve for X. Now remember, when we are setting up a proportion, we're always going to be given 3 pieces of information. So if you look at the drawing, you can see the 3 pieces of information we're given. We're given the length of the office building's shadow, we're giving the height of the person, and we're given the shadow length of the person. So again, 1 out of those 4 pieces of information is missing, and that's what we're solving for, which is X, and X is the height of the building. Now, all we need to do is use our cross multiplication. So let's go ahead and do that. Let's multiply 3 times X. So that's going to give us 3X. And then let's set that equal to the product of 55 times 6. So 3X equals 55 times 6. Let's simplify that right side. So 55 times 6 is 330. Now, in order to get X by itself, we need to divide each side by 3. So that's going to give us X equals 110 feet. So it's very important to use units when we express our answer. Our answer is X equals 110 feet. So if we want to, we can go back to the original picture and write 110 feet as the office building height. So what we've done is we've just estimated the height of the office building using a ratio of shadow to height. So all of the measurements that we used were things that we could easily measure, like shadow length on the ground or a person's height. We used the ratio to solve for an estimate of the office building's height. Thanks for watching.